So this is just going to be a quick look at the maths involved in doing splines or tracing something through a path. It's something that's really, it seems like it's a lot more complicated than if you've never done it before. You might think it's complicated or the maths is complicated, but actually it's not that difficult to do. And if you're making video games or doing graphics or anything, this is definitely something you should know. So it's very easy to do. So this isn't a Unity tutorial, but I am doing this in Unity just because it's got the ability to draw lines and boxes, which is all I need for this. So I'm going to make a simple thing just to show how to trace a ball through a path, and I'm going to do it in here. So I'm going to create a script called Spline. I'll call it Splines, and I'm going to put it on an empty in here. So remember, this isn't just, I don't really use Unity, but this is just very easy to draw stuff in here. So this is what I really want. Right. So I'm just going to draw stuff in the editor. I'm not actually going to draw it in the game. I'm going to paste some code from the Unity website. Let's just get some drawing to start with. This will, I think on draw gizmos, this will just draw a sphere at the position of the object I've just created, I think. There we go. So let's just move us back to the origin. Not that we need to be there, but... So, what I want to do is just to start with, I want to just draw a line between this object and another one. So I think I just put another transform in there. Thanks for correcting that for me. I'll just call this, I'll call it last. And I think I want to draw a line from where I am now to last position. So that should just draw me a line in yellow from me to another game object that I specify. So that's what I want to get going. I need to specify the other game object. I called this one last, didn't I? Last. And let's attach it to that one. And let's just show where it is as well. Let's just put it in blue. There we go. It's putting these things in weird places. There we go. So that's just drawing a line from me. Let me just turn that on as well. Yeah, so it's drawing a line from me to the last place. So the first thing I'm going to do is I'm going to create a really, really basic spline. It's going to be a spline that's completely straight. So I'm going to just take a ball. I'm not actually going to draw the spline. I'm just going to path a ball from the start to the end through that spline. And in this case, the simplest spline that I can make is a spline that doesn't even have a curve in it. So I'll leave the line in just so we know where it is. And we need that draw sphere back. And we want to draw... let's just draw it where we are to start with. I think it requires a radius as well. Let's just do that like that for now. Is that me? Am I going to get that sphere there? Invalid token. What's my invalid token? Oh, I didn't. It needs to be a float. Oh, there we go. It's pretty huge, but there it is. Let's just move this a bit further away to compensate for that. So I need to now move this along this line from start to the end. And the way I'm going to do that is I am going to look up something on Google. And I'm going to look up Bernstein Polynomials. So this is what I'm going to use to draw my splines. And as you can see, it's a scary maths page. Well, it's a reasonably scary maths page. It's got some, it's got all these numbers and binomial coefficients, and there's a graph here and some stuff. And then it starts going crazy down here. We've got all these sums of everything, and oh, what's going on? We're approximating continuous functions. But the information we actually need is here. The first few Bernstein basis polynomials are, and they're down here. So what we've got here is a bunch of coefficients that we can use to multiply the points we've got in space, like our start and end position. And if we multiply them by these coefficients and then add them together, we get a new point. And that new point will be the point that we're going to trace along. So we're going to trace this point like parametrically from, you can see on the graph here, it starts at 0, goes to 1. So this x is a value from 0 to 1. And all we have to do is multiply the coefficient by each of the points and then change this x value, and it should get us our ball moving from one place to the other. So you can see we've actually got there's a case here that if we've just got 1 point, which would be hard to like interpolate from 1 point to 1 point, which is just itself, we just multiply it by 1. So that I'm not going to do this case, but it does make sense that if you just have a position in space, you multiply it by 1, you just get back the position in space. So the trivial case is really that, hey, if I want to interpolate from myself to nowhere else, I just stay where I am. So it even works in that case that this first Bernstein polynomial is just 1. But we're going straight in at the second one here, which is, these are our coefficients here, which is 1 minus x and x. So we'll stick those into here. We're going to create a new position. Remember, I've got my position and the end, so I've got my 2 points. I now want a new position, so that's going to be a vector 3. I'll call this P1 because it's the 1 on here, I think. So I want to take my position and I want to multiply it by 1 minus x. So I haven't got the x value yet, but I'm going to put it in here. I'm actually going to call it t because it's usually called t for time, but it's basically like a parametric function where I'm going from 0 to 1. So t will default it to 0, and I think we can put a range 0 to 1. So that's going to be my parameter that I'm going to change. So 0 to 1. 0 is going to be the start of the line and 1 is going to be the end. So the first position gets multiplied by 1 minus x. So that's 1 minus t in my implementation. And then I'm going to add to that. Let's just bracket that, so we know we don't get anything wrong. So that's the first parameter. The second one is the last position, and that's going to be multiplied by just the x value, which is t in my case. So my 2 Bernstein coefficients are there. It's that one and it's that one, and I'm just multiplying them by the 2 points that I've got, and then instead of drawing the sphere at just position, I'm going to draw it at my new one that I've made. So not too tricky, and I've only got 2 points, so let's see if that works. Parameters are on here. So there's my t value going from 0 to 1, and there it is. So 1 puts me at the end of the line, 0 puts me at the start of the line, and any value in between, I'm just like somewhere in between those 2 points. So you might be thinking, yeah, that's not a spline, that's just a straight line, and that's pretty much what it is. But I'm doing it this way so I can just show that if you can do that, then you can do a curve as well. And if you can do a curve, you can do an even better curve, because it's all done in pretty much the same way. As long as you can Google Bernstein polynomials and look them up, then you're all good to go. So I'm going to leave that one in there. So that is also called linear interpolation. You'll hear this referred to as linear interpolation, or you'll also hear it as lerping. But when you hear people say lerp or linear interpolation, they're actually doing this. But from my point of view, linear interpolation and splines are basically the same thing, because now all I'm going to do is I'm just going to add another point to this. So I'm going to add a middle point, and let's start by drawing our line. So I'll copy that. So this one I'll do in blue. And we want to go from the position to the middle. Whoops, didn't get that right. From the middle, and then I want to go from the middle to the end. Or if I cut it last, cut it last. So let's see what we get. I think I need to give that, I need another game object called middle. Stick that on there. Let's just do that so we can see it. So there we go. So it's putting these things in weird places. So I've now got another position there. So I've got this yellow object's going from here to there, and I've got a blue line that goes out to there and then back to the end, so to speak. Just going via quite a long way. So really what I want to do now is I want to be able to do the same thing I've done with this ball, but I want to take it from here to there via that point. There we go. And essentially, you'll see that we're going to do it in exactly the same way we did the other one. So I'll copy that. Except now, instead of 2 points, I've got 3. So just put that in there. So let's look up the polynomials for the next order. So the first one is 1 minus x squared. So so that's 1 minus x times 1 minus x, except it's t. So you can see that's my first position. I'm multiplying it by that coefficient there. The second one is 2x times 1 minus x. So this is the middle position we want now. 2 times t times 1 minus t. Add those together, is that right? 2 times t times 1 minus t, yeah. And the last one is just t squared or x squared. So that's the last position times t times t. So as you can see, the linear interpolation isn't much different from a spline, or sometimes it's called a Bezier curve or spline. This is essentially the same thing, except we're going through a middle position to get to the end. So let's see if that works. Let's set that one to blue. So I should have the yellow ball and the blue ball now. Let's have a look. There it goes. There we go. So the yellow one's still following like the linear path, and the blue ball is just going from the start to the end via that middle point. So it's really quite trivial. Once you know how to lerp something, you know how to make a Bezier curve. It's just different coefficients passed in, and you need an extra point. And once you do that, well, guess what? You can do a cubic curve. I mean, these are also sometimes called quadratic curves as well. Quadratic curve, because it's got that t squared value in down there. It's always a bit annoying that quadratic, like squaring something's called quadratic, but cubing something's called cubic. So down here, we're going to do the cubic version. These are sometimes called cubic curves or splines. I don't know if they've got any other names. They probably do. But now we need 4 positions. So we're going to go from the start to the end, but through 2 positions in the middle. So I'm just going to call this middle 2, which is a pretty bad name, but I'm going to do it anyway. Let's draw the line. Let's do this in red. Again, apologies if you're colorblind. Middle. So we go from the start position to the middle, from the middle to middle 2, and then from the middle 2 to the end. And then let's get rid of this for now, and let's just see if we get our line. See if that works. Yep, so we need our middle 2. Let's just make it so that you can see that as well. Where is it? There it goes. So assign it. Oh, assign it to that middle 2. There it is. Oh, that's a bit of a funny path it's going to take, isn't it? So yeah, so we should now be able to make a red ball that should be able to go from the start to the end, but through those 2 points over there. So that's really what we want. Why have I not got a... Oh, I just can't see it. So let's see if we can get that one drawing as well. So here we go. So this is just for prosperity. We'll want a middle 2. So let's just fill these in correctly. Let's just look up. So this is the next line here. So we've got 1 minus x cubed for the first parameter. So there it is. That's 1 minus x, 1 minus x, 1 minus x. The next one, 3x times 1 minus x squared. That's 3t times 1 minus x times 1 minus x. I mean, if you're doing this for real, you'd want to tidy this up and not duplicate all this maths that we keep doing here. And as you can see, you could pass these coefficients in as like a little array as well. So it's quite convenient for them to just be coefficients. The third one is 3x squared times 1 minus x. So 3t times t times 1 minus t. Is that right? Yep. And the last one is just t times t times t, t cubed. Hence the cubic part. So hopefully, oh, drawn the wrong one there. Hopefully this gets me a red. I've got yellow, red, and blue. So let's see if we get the third one. There we go. So we're already getting somewhere here. So there we go. So we're tracing. They all go from start to end, but they all trace through their little points like that. And we should be able to just move these around and it changes where they are. So you can do this in 2D or 3D, it doesn't matter. But as you can see, the maths is just really simple. So like quite often when people will say, hey, I'll lerp that, or I'll make a curve or a spline or something like that. And you can suddenly realize that they are pretty much all just the same thing. And this is done so much in computer graphics and everything. Like if you've ever seen a font, this is how fonts are done. All the curves in fonts are expressed as things like this. So that's really cool. That's something that you should definitely know if you're ever making a video game. So if you wanted to make like a big path that went a long way, you'd have to just string loads of these together and get it to trace that path basically. But once you can do one of these, you can link more together and start interpolating in different ways like that. So there's a little bit more complexity to that, but essentially this is the basis of it. And it's all based around the fact that you know how to look up, how to use Google, and how to look up these Bernstein polynomials. And here they are. And there's another one here. You can go to another, like if you need to interpolate through 1, 2, 3, 4, 5 points, you can do that as well. I'm not going to do that one, but that will work as well. And there might be more, or you can just make up your own. Because one of the nice properties about these functions is that they add up to 1 basically. So 1 adds up to 1. 1 minus x times x adds up to 1. And if you add up these coefficients as well, they add up to 1. So you're never going past the end of the ball should never go past the end of the point you went to and shouldn't go before the start. So that is pretty easy to do, and it's well worth knowing. You can implement this. Once you know this, you can implement splines in just about any programming language or environment that you're doing at all. So I hope you find this useful, and get splining, if that's even a word.